Presentation is on CRIDA. That's a method for adaptation planning, adaptive planning. You can also use it for adaptive design. It has been developed by Deltares together with Rijkswaterstaat and in the United States by the Army Corps of Engineers and Massachusetts University. The ideas that I will present and the CRIDA method has been developed more from a strategic perspective. So in this top-down approach, the question is, how can science, we have a scientific team, we have asset owners, I talk a little bit about that in my presentation, how can science help to improve decisions? So the usual mode of engagement between scientists and asset owners has been prediction-centered, and in that mode of approach, the scientists are, and then I talk particularly more about the climate scientists, so not us, let's say, try to reduce the uncertainty that affects the decision of the decision maker by saying, well, this is our most likely prediction of the future. And then the decision maker can say, okay, if the future is going to be future A, then my best option or measure would be, well, measure 1, for example, yeah? But there's a difficulty with this approach on the climate change, because on the climate change there's a cascade of uncertainty. So if you look at the top-down approach, it starts at the more at the causes, which, if we talk about climate change, that is the population growth and economic growth, which is causing greenhouse gas emissions, and that leads to climate change at the global and regional level. And in the end it will have influenced the hydraulic cycle. So it can be increased precipitation or reduced precipitation, increased sea levels, and that will have an effect on our water management, and we have to take measures. So this is a nice illustration where the scientist is saying to the decision maker, well, you have a problem because the climate is changing. But of course the decision maker will respond. And his natural question, maybe it's your question, is, okay, tell me how much the climate is changing. Yeah, because then he wants to make the best decision under that prediction. And this is the explosion of uncertainties I talk about. Yeah? So particularly towards the future, 50 years from now, there's a large bandwidth. And this makes it difficult to engage with each other under this prediction-centered approach. Yeah? A scientist is more interested in the quality of information. So can I provide accurate climate predictions? And how can I improve my predictions? Or how can I improve my models? Or maybe I should do improve downscaling from global models to regional scale. So a different approach has been introduced, which is called the bottom-up approach, and that's what the CRIDA is based on. And that approach starts by looking at the vulnerability of the system. So it doesn't start at the top with the climate change scenarios, but it starts by looking at the system that the asset owner is responsible for and trying to determine what is the vulnerability of that system to potential failures. Yeah? So that's the first step, and then only at a later stage you use the climate change scenarios to see, okay, what's the possibility that I will be in the vulnerable domain. So what is interesting about this is that the bottom-up approach, it shifts the attention from what we do not know, yeah, that is how much the climate will change and what the uncertainties are, to what we do understand very well, and that's our water management system. Yeah? And that also counts for the CRIDA approach. And if you look at these steps, it's very similar to our, in fact, our strategic perspective of the FAIR framework. So the first step is the decision context, and there you're trying to define, well, what's actually your problem, and particularly important is to describe the objectives and what are performance metrics. Yeah, so making the objectives more quantitative. And then I said you can use at that stage the climate scenarios to do an assessment of how plausible it is that you reach a certain tipping point. So to describe the decision context, you need to know what are the external drivers. So the stressors that I cannot control and that influence my system. This can be climate change or population growth and also economic development. What are the design parameters? So the things that I can control. So that's more the adaptation measures and strategies. And what are my performance metrics? And that is the outcomes that you are interested in. And they relate to social and economic impacts. And to relate all of this together, you need, of course, a systems model, which preferably also includes not only the natural system, but also the social and economic system. At the highest level, you have your objectives for the management of your system, so for the asset management, which describes in a more qualitative way the desired result. So it can be to reduce the flood risk, but then you need to make it quantitative in order to do the analysis. So you need to say, what is the outcome that I'm particularly interested in? And then if you know that, then you can start to say, okay, this is what we find acceptable.